All right, so today we're going to talk about the distributive property. We'll use the distributive property to evaluate expressions and to simplify expressions, okay? So if we look at this original problem here, it says, John burns approximately 420 calories per hour by inline skating. The chart below shows the time he spent inline skating in 1 week. So you can see the days and how many hours he spent inline skating. To determine the total number of calories that he burned inline skating that week, you can use the distributive property. So let's take a look at that. There are two methods you can use to calculate the number of calories John burned inline skating. So we can find the total time by multiplying by the calories burned per hour, or you could find the number of calories burned each day and then add them to find the total. So for example, in method 1, we have 420 calories burned, and then we have all of the hours from every day. We can add all those together and be 7 and then times the calories and get 2,940. Or the second way, we could say 420 calories times the first day, which is 1 hour, plus 420 times the second day, which is a half hour, and so forth and so on until we get all 5 days covered. Then we add the answers together and get 2,940. So two ways to do the same problem. And either way, like I said, gives you the same total, and this is an example of the distributive property. All right. So basically what you're probably familiar with when looking at the distributive property are examples like these. So where you have a number outside of a grouping and numbers inside the grouping or variables. So you could do 3 times 2 and then 3 times 5. So you have to multiply times each term inside the parentheses. 4 times 9, 4 times 7, okay? And then, of course, do whatever operations in the middle. Addition in the first problem, subtraction in the second problem to get your answer. All right, let's look at a word problem. It says, a group of 7 adults and 6 children are going to the University of South Florida Bulls baseball game. Use the distributive property to write and evaluate an expression for the total ticket cost. So we are to do this problem using the distributive property. So you need to find the cost of each ticket and then find the total cost. So we know that there were 7 adults and 6 children. Here are the ticket prices. So we can take a look at what we need to charge. Well, if there's 7 adults and 6 children, that's 13 people. And here it says groups of 10 or more is $2 a ticket. So we could say $2 times the sum of 7 plus 6. Then we multiply 2 times 7 and 2 times 6, which is 14 and 12. Add them together to get the total cost for $26. That would be doing the problem as a distributive property, okay? All right. You can also use distributive property to make mental math easier. So we are to use distributive property to rewrite 7 times 49 and then evaluate it. So 49 would be the same thing as saying 50 minus 1. So I could say 7 times the difference of 50 minus 1, then it's simply 7 times 50 and 7 times 1, which would give me 350 minus 7, or 343. Just makes the math a little bit easier to do in your head. All right, so this is where you can pause the video, work 2A and 2C, and see how you did. When you're done, come back and check your answers. All right, let's see how you did. So I could break up 304. I could say 300 plus 4 times 15, okay? Then that would be 300 times 15 plus 4 times 15, and that's going to give me 4,500 plus 60 for 4,560 as the answer, okay? So it just makes it a little easier. On this one, I would go 200 plus 10 times 5, then that would be 200 times 5 plus 10 times 5, which of course is 1,000 plus 50, or 1,050. Okay? So you're just breaking up that bigger number, making it a little bit easier to work with. Okay? All right. So to simplify expressions, you can use algebraic tiles to investigate how the distributive property relates to algebraic expressions. So this is just an example of ways that you can see how distribution property works. So if I look at the tiles over here, I can see that there are 3 x tiles and there are 6 1 tiles. If I was going to find the area of the whole thing, I would have to add everything together. So it'd be x plus 1 plus 1, x plus 1 plus 1, plus x plus 1 plus 1, okay? Or remember, to find area would be I'd multiply the two sides together. So I could say 3 times x plus 2, which would give me 3x plus 6. So I'd multiply the 3 times the x and 3 times the 2. Okay? All right. Now, the problem says rewrite each expression using distributive property, then simplify. So I have 7 times the difference of 3w minus 5. So I can use the distributive property, and I take 7 times 3w and 7 times 5, which is what we have right here. And that would be 21w minus 35, which that's as low as we could go. There are no like terms, so that's it. We're done unless we knew what w is, and we don't. All right, on b, it would be 4 times 6v squared, 4 times v, 4 times 3, which is what we have next to it. And then when we multiply it out, we end up with 24v squared, 4v, and minus 12. Okay? Now again, these are all unlike terms, so that's the answer. There's nothing else we could do unless we knew what v stood for. All right, now let's talk about like terms. So these are terms that contain the same variables with corresponding variables and have the same power. So if we look here, we have 3 terms. We have 5x squared plus 2x minus 4. So they would have to be like terms, they would have to have the same variable and the same power or the same exponent. In this one, they do not. But if we look over here, we have 6a squared plus a squared plus 2a. So these two are like terms. We could actually add those together. And don't forget, if you have just a variable like this, there's always a 1 in front of it, okay? So that would be 7a squared plus 2a, okay? All right, so for example, if we had 4k plus 8k would equal 12k. And we know that because 4k and 8k are like terms. They have the same variable with the same power, same exponent. So all we have to do is add the coefficients, 4 plus 8, and keep the variable k. And that would be 12k. All right, let's look at this problem. It says an expression is in the simplest form when it contains no like terms or parentheses. So we have a problem that says 4 times the sum of a squared and 3ab, and that is subtracted from ab. So we would have to use, they say the multiplication identity, and that's just because we're putting a 1 in there. Because remember, if there's no number in the coefficient spot, then it's going to be 1. Then we would use the distribution property. It would be 4 times a squared and then 4 times 3a, which would give me 4a squared plus 12ab minus the 1a. Then I could do the distribution property again, and that is where I can pull out the 12 and the negative 1 based upon them being like terms. They have the same variable with the same exponents. And then I can simply do substitution. 12 minus 1 is 11, so my final answer is 4a squared plus 11ab. Okay? And that's all there is to it. All right. Now you guys can pause the video, try 4a, 4b, 4c, 4d on your own. You're going to simplify them. If not possible, write simplified. When you're done, come back and check your answers. All right, let's see how you did. So 6n minus 4n, they are like terms. They have the same variable with the same exponent. So all I have to do is so I could rewrite this if I wanted to as 6 minus 4n, which would be 2n, okay? And then let's go to 4c. On 4c, we have like terms of 2y and 8y. So all I have to do is go 4y cubed. Now 2 minus 8 would be negative 6, so negative 6y plus 5, okay? And that's it. It's done. That's all I can do. Everything else is unlike terms. Let's go 4b. Look at 4b. We have b squared, we have 13b, and we have 13. None of those are like terms, okay? Because this one the first one has the power of 2, the second one has the power of 1, and the third one has no variable. So this would just be simplified, okay? And then for D, 7a plus 4 minus 6a squared minus 2a. So I would have to change I would want to change some things around first. I would want to use the community property and change a few things, okay? So I would go 4 minus 6a squared minus 2a plus 7a. Then I could say 4 minus 6a squared, negative 2 plus 7 would be 5a, okay? And now I have no like terms, so that could be my final answer. All right. Now it says use the expression twice the difference of 3x and y increased by 5 times the sum of x and 2y. So A says write an algebraic expression for the verbal expression. So twice the difference of 3x and y would give me that expression. Increased by is addition, and 5 times the sum of x and 2y would give me that expression, okay? Because sum means an addition problem, or the answer of addition problem from x and 2y, and it's 5 times that. And then on the first one, it is a difference, so that's a subtraction problem between 3x and y, and it's twice that, so it's multiplied by 2, okay? So then I can use the distributive property. It tells me to simplify the expression and indicate the properties. That means I have to write down what properties I used. So the distributive property, that's where I am multiplying each one of the terms on the outside to the terms on the inside. And so that's what we've got in the first line. Then we just simply multiply, and that leaves me with 6x minus 2y plus 5x plus 10y. Then I could use the commutative property and move things, commutative property of addition, and move a couple things around. I can move that positive 5x onto the other side of the negative 2y. Now I can use the distribution property. And I can say 6, these are like terms, so 6 plus 5 times x, and these are like terms. And don't forget to take the sign with it, okay? So if it's negative, minus 2y, it would be negative 2 and 10. Now, 6 plus 5 is 11, plus negative 2 plus 10 is 8, so this ends up being my final answer, okay? All right, let's take a look here. Use the expression 5 times the difference of q squared and r plus 8 times the sum of 3q and 2r. So, on this one, I would put, for my expression, well actually pause it, try to complete it on your own, and then come back and see how you did. All right, so I would write 5 for the expression times the difference of q squared and r, so the difference of q squared and r, and then that is plus 8 times the sum of 3q and 2r. So that would be my expression I'm working with. Now it says simplify the expression and indicate the properties used. So we're going to come down here and work down here. So the first thing I would do is the distributive property. So I would go 5 times q squared plus 5 times negative r plus 8 times 3q plus 8 times 2r. Okay? And that is the distributive property. Okay? Then I would just simply multiply that, and I would get 5q squared plus a negative. So I can actually write that as minus 5r plus 24q plus 16r, I believe. Okay? And that would be multiplying. And I have to write these steps out because it told me to. It asked me which rules am I using, which property. So then I could use the commutative property. And by using the commutative property, I can move a couple of things around. I can move, remember I can only move either addition or multiplication around. So I could move the 24q and 16r around. So I would go 5q squared plus 24q plus 16r minus 5r. And that's the commutative. Of addition. Okay? Then I can use the distributive property again and go 5q squared plus 24q plus 16 minus 5r. Okay? And then finally, I can use substitution, and I can go 5q squared plus 24q plus 11, just substitute 11 for the 16 minus 5, r. Now I have no more like terms because I have two q's, but one's squared and one is not. So therefore, they're not like terms. So that's as far as I could go, and this would be just substitution. Okay? And that's all I can do. All right. This last little tidbit was just the coefficient of a term is the numerical factor. For example, in 6ab, the coefficient is 6. In the coefficient, or in x squared to the third, the coefficient is 1/3. And the reason for that is 1/3 times x squared would give me x squared over 3. Okay? In the term y, if you just have a variable, there's really a 1 in front of it. So the coefficient would be 1. So it's just letting you know what a coefficient is. Okay? All right, if you have any questions, let me know. Otherwise, have a good day.